Namaste. In this lecture, we will study habitat destruction, and specifically, we will examine four distinct ways in which human activities impact natural habitats. These four impacts are habitat degradation, habitat fragmentation, habitat displacement, and habitat loss. Let us begin. Let us start by laying out the framework for this lecture. There are four key ways in which a habitat can be impacted by human activity. The first is habitat degradation, where the quality of the habitat declines, but the habitat remains in some usable form. The second is habitat fragmentation, where a continuous habitat is broken into smaller, disconnected pieces. The third is habitat displacement, where wildlife is pushed out of its preferred habitat and into less suitable areas. The fourth is habitat loss, where the quality falls so severely that the habitat becomes completely unusable by the species that depended on it. We will go through each of these in turn, beginning with habitat degradation. Habitat degradation is defined as the process by which habitat quality for a given species is diminished. Degradation does not mean the habitat disappears entirely. The physical space may still exist, but its ability to support a species, to provide food, shelter, breeding grounds, and safety has been reduced. Think of a forest that still has trees standing, but where we have excessive invasive alien plants, or where water sources have become polluted, or where noise and human activity have made conditions unsuitable for many species. The forest is still there, but its quality as a habitat has declined. It is a process, not a single event, and it can affect different species to different degrees. A habitat highly degraded for one species may still be adequate for another with less demanding requirements. Now let us look at the agents that cause habitat degradation. The first major category is contamination, the introduction of harmful substances into the air, water, or soil. Air pollution affects the health of organisms and alters soil and water chemistry through acid rain. Water pollution introduces industrial effluents, sewage, or agricultural runoff into rivers and lakes. The third subtype shown here is eutrophication, and the two images illustrate it directly. On the left, we see a clear, healthy river. On the right, the same water body has turned a thick, opaque green, covered by algal growth. Eutrophication occurs when excessive nutrients, say from fertilizers or from sewage, enter a water body and trigger a rapid explosion of algae. As the algae die and decompose, bacteria consume dissolved oxygen, causing oxygen levels in the water to crash. Fish and other aquatic organisms suffocate and die, rendering a once diverse habitat now largely uninhabitable. The process affects rivers, lakes, ponds, and coastal waters, and is one of the most widespread forms of water body degradation globally. This slide adds a fourth subtype of contamination, pesticides and accumulative toxins, and introduces biomagnification. The data comes from Clear Lake in the United States, documented by Rachel Carson in The Silent Spring. A pesticide called DDT was used in that lake. In the water, the concentration was 0.01 parts per million, so a very low concentration. In planktons, it rose to 5 parts per million. So there was an accumulation in the bodies of the planktons. In fish, it reached 40 to 300 parts per million. And in piscivorous birds, that is, birds that eat fish, it reached 1600 to 2500 parts per million. Now, this dramatic increase at each trophic level is biomagnification. Things are getting magnified, things are increasing in size, in this case, concentration. Organisms at the top of the food chain receive the greatest toxic loads, even without ever contacting the pollution source, which is why pesticide contamination can degrade entire ecosystems far beyond the original site of application of pesticides. The second major causal agent for habitat degradation is trash. Solid waste introduced into natural environments degrades habitat in several ways. Two specific forms are highlighted here. The first is ghost nets. These are fishing nets that have been lost, abandoned, or discarded in the ocean. They continue to drift through marine habitats for years or even decades, trapping and killing fish, marine mammals, sea turtles, and seabirds indiscriminately. They are called ghost nets because they fish invisibly and endlessly, with no one controlling or retrieving them. The second form is plastics. Plastic waste has become one of the most widespread forms of habitat degradation on the planet. It enters marine and terrestrial environments at enormous scales. It persists for hundreds of years. Animals ingest plastic, become entangled in it, and suffer physical harm from it. The photographs on this slide show us the real world impact of this type of trash. We can see a crab entangled in a ghost net and a ghost net draped over a coral reef in an underwater image. We also see penguins on a beach surrounded by plastic litter. These images make clear that plastic and ghost nets are not abstract pollution problems. They are direct physical hazards that degrade the habitat quality of marine and coastal environments for a very wide range of species. This slide continues that theme. We can see plastic extracted from rhinoceros dung in the core area of Manas Tiger Reserve, monkeys interacting with plastic waste, and a Nilgiri tar in Mukurti National Park in a habitat visibly contaminated with plastic litter. What these images collectively tell us is deeply concerning. Plastic waste has penetrated not just human dominated landscapes, but the interiors of our national parks and tiger reserves. These are among the most strictly protected areas in the country. And yet, plastic is present even there, inside the dung of a rhinoceros, in a core zone. This is a measure of how pervasive plastic pollution has become as a form of habitat degradation. This tells us that the problem of trash as a causal agent for habitat degradation extends into forests and hills, besides oceans and coasts. When wild animals ingest plastic or are surrounded by waste, the quality of their habitat is genuinely diminished, even if the underlying landscape remains intact. Building on the list of causal agents, the third factor is soil erosion. Soil erosion occurs when the top layer of soil is removed by wind, water, or human activity. The topsoil is the most biologically active and nutrient rich layer, and when it is lost, the land becomes less able to support vegetation. The consequences extend far beyond the eroded slope itself. Hill slopes get destabilized, air quality is reduced by dust, and the sediment carried into rivers and lakes causes sedimentation that degrades aquatic habitats, reduces water storage capacity, and can even alter the course of rivers over time. The photograph on this slide shows a massive landslide on a slope that was not adequately protected by vegetation. When surrounding slopes remain forested, the unprotected face has given way entirely, exposing bare rock and subsoil. Vegetation does not merely grow on healthy soil, it is also what holds soil in place. Remove it from a slope, and erosion can be rapid and catastrophic. The fourth causal agent is changes to fire regimes. Fire is a natural part of many ecosystems. Many grasslands and forests are adapted to periodic, low intensity fires that clear dry vegetation and stimulate new growth. Human activity disrupts these natural cycles in two ways. In some areas, fire suppression allows unnatural accumulation of dry fuel that eventually lead to catastrophic uncontrollable fires. In other areas, deliberate burning for land clearing or to flush out game occurs at frequencies that exceed what the ecosystem can recover from. When fire regimes are altered in either direction, the composition of the habitat changes, favoring a smaller number of fire tolerant species and excluding those that were adapted to the original conditions. The fifth causal agent is water overexploitation. Fresh water is not only a resource for human use, it defines many ecosystems. Rivers, wetlands, lakes, and floodplains are habitats in themselves. When water is extracted in excess, say for irrigation or industry or urban use, the river flows decline, wetlands shrink, and groundwater tables fall. Aquatic organisms face reduced habitat area and degraded water quality, as lower flows also concentrate the pollutants that are there. The loss of water also changes vegetation structure around the water bodies, further altering the habitat quality for terrestrial species. The next causal agent is deforestation. Forests are among the most species rich habitats on the planet. When forests are cleared for timber, agriculture, mining, or settlement, the habitat structure that hundreds or thousands of species depend upon is destroyed. Even before complete clearing, selective logging degrades habitat quality by opening the canopy, altering the microclimate, and removing large old trees that serve as nesting and denning sites. Deforestation also disrupts the hydrological cycle, contributing to soil erosion and reduced water availability in the surrounding habitats. This slide presents satellite imagery comparing forest cover across three locations in Madhya Pradesh: Balaghat, Umaria, and Bhopal, at two different time points. The top row shows images from the early 2000s, and the bottom row shows images from 2018. The comparison is striking, and each location tells a different story of deforestation. In Balaghat, the forest loss is driven by mining. What was largely intact forest in 2006 has been heavily scarred by 2018, with large areas of bare, excavated land visible. In Umaria, the forest has been cleared for conversion to agricultural fields, with the patchwork of cultivation clearly replacing what was once continuous forest cover. In Bhopal, the agent of change is infrastructure, specifically a dam whose reservoir has submerged forested land, with the water body and its altered surroundings clearly visible in the 2018 image. Each location makes an important point. Deforestation is not a single phenomenon with a single cause. Mining, agriculture, and infrastructure each produce it through different pathways. And addressing deforestation requires understanding and tackling each of these drivers separately. The seventh causal agent is desertification, the process by which fertile land progressively becomes drier and less able to support vegetation, eventually taking on desert like characteristics. Two human activities are mainly responsible. The first is overgrazing. The photograph shows a landscape in Rajasthan with largely open, bare ground and large herds of goats and sheep. Only a few scattered trees remain. The animals are so numerous that whatever scanty vegetation once existed cannot regenerate. In dryland areas, that sparse vegetation is what holds the soil together and keeps the desert at bay. Once it is gone, the desert spreads. The second is faulty cultivation practices. For instance, using flood irrigation instead of drip irrigation. Excess water applied to the soil brings dissolved salts to the surface, and as water evaporates, those salts accumulate. This salinization further kills vegetation, accelerating the very process of land degradation we are trying to prevent. The eighth category covers modifications to water systems, draining, dredging, damming, and similar interventions. Wetlands are drained to create agricultural or urban land. Rivers are dredged, disturbing benthic habitats and altering flow dynamics. Dams block the movement of migratory fish, change sediment deposition patterns, and transform riverine ecosystems both upstream and downstream. Floodplains lose their periodic flooding events, and with them, the seasonal habitat dynamics that many species rely upon. Each of these interventions degrades the habitat for species that evolved in these water related environments. The ninth causal agent is overexploitation of biota, the excessive harvesting of organisms faster than they can reproduce. This does not only affect the targeted species, removing top predators destabilizes prey populations. Removing keystone species can transform entire habitats. The chart on this slide shows whale populations for 8 species, with 1890 as the baseline of 100% and 2001 figures alongside. Whaling records are extremely robust, so we can be confident in these numbers. The blue whale, the largest animal on Earth, is now at just 1% of its 1890 population. The bowhead and right whales are at 11%, the fin whale at 14%, the humpback at 18%. This is what overexploitation does. The same outcome plays out through overfishing, illegal wildlife trade, and excessive extraction of timber and fuel wood across habitats worldwide. Another causal agent is the introduction of exotic species. When a species is introduced into a habitat where it did not evolve, native species have no evolved defenses against it. Some become invasive, spreading rapidly and displacing native species. The photograph shows a parakeet feeding on Lantana camara, an invasive alien plant that has spread widely across India. Many exotic invasive plants are profuse seeders, and birds like this parakeet eat their fruits and disperse the seeds through their droppings, accelerating the plant's spread deep into natural habitats. As invasive plants replace native vegetation, the food and shelter available to native animals changes fundamentally. Even where the physical landscape remains intact, this biological transformation constitutes genuine habitat degradation. There are many more causal agents beyond the 10 listed here. This list gives us an important but not exhaustive picture of how habitats are degraded. Now let us move to the second of our four impacts, habitat loss. Habitat loss occurs when the quality of the habitat falls so low that it is no longer usable by a given species. The photograph on this slide shows a forest after a ground fire. The canopy trees still carry green leaves, but the entire ground cover and understory have been burnt away, with ash and smoldering debris covering the forest floor. For species that depend on the understory and ground layer, species like insects, reptiles, small mammals, ground nesting birds, and countless invertebrates, this habitat has been effectively lost, even though the trees above remain standing. This illustrates an important point. Habitat loss does not always mean the complete physical destruction of the habitat. If the quality falls below what a species needs, the habitat is lost for that species, regardless of what remains. Degradation is the process of declining quality. Loss is the threshold at which that quality is no longer sufficient. Now, let us turn to the third of our four impacts: habitat fragmentation. Fragmentation occurs when a natural landscape is broken up into small parcels of natural ecosystem, isolated from one another within a matrix of land dominated by human activities. So, we are breaking up the ecosystem into smaller parts. It involves two distinct changes simultaneously: loss of habitat area and isolation of what remains. The photograph on this slide captures this vividly. A road runs straight through a forested landscape, dividing it into a left fragment and a right fragment. The forest on both sides may look intact, but for any animal that needs to move across this landscape, the road is a barrier. A species living in one fragment cannot freely access the other. And this isolation has profound consequences for populations, genetic exchange, and ecological processes, even when the fragments themselves appear undisturbed. Why do larger fragments support more species? Well, there are three reasons. First, larger fragments have more diverse environments, more soil types, water features, and vegetation layers, which means more niches and more species. Second, larger fragments hold both common and uncommon species. Small fragments tend to retain only the most abundant generalist species. Rare specialists are lost first. Third, smaller fragments support smaller populations, which are more vulnerable to extinction through random fluctuations or chance events. The photograph shows a macaw, a species of the Amazon rainforests, which are today among the most heavily fragmented tropical ecosystems on Earth. The causal agents of habitat fragmentation fall into two main categories. The first is construction of roads, railways, dams, and other structures that cut through or divide natural landscapes. Roads and railways cause fragmentation in several distinct ways. The photograph shows a dead animal on the road. Killed by a vehicular hit, road and rail mortality is a direct and significant cause of wildlife death. Railways additionally pose a particular risk to large animals like elephants, which can be struck by fast moving trains at night. Beyond killing animals, roads and railways also act as physical barriers that many species are unwilling or unable to cross, and as psychological barriers. The noise, light, and human activity associated with them can deter even animals that could physically cross. Roads also open up previously inaccessible forest to encroachment, poaching, and invasive species. Dams fragment both river ecosystems and forests. They block fish movement, transform the flow regime, and their reservoirs physically divide forest landscapes, cutting off terrestrial species that cannot swim across. The second major cause of fragmentation is conversion of land for agriculture, which creates a human dominated matrix that separates remaining natural patches from one another. We now look at how fragmentation unfolds as a process through a series of diagrams. The first stage is dissection. On the left, we see a continuous green landscape, a grid of trees representing intact forest. On the right, the same landscape has been cut through by roads, dividing it into sections. The total area of green is more or less unchanged. And this is precisely the point the road proposals in forest areas often exploit. Project proponents typically cite only the minuscule percentage of forest area that will be physically diverted for the road, perhaps a fraction of a percentage, while saying nothing about fragmentation, noise, pollution, increased human access, poaching pressure, and invasive species that come with it. The diverted area is small. The ecological damage is far larger. Dissection is the beginning of that damage, and the diagrams that follow will show us how it compounds. The next stage is perforation. The diagram shows areas of green replaced by settlements and grazing, holes punched into the forest matrix. The photograph shows cattle grazing inside forested land. But how does this begin? Consider a small samosa shop that opens up by the roadside. Entirely reasonable. Commuters need refreshment. And here is someone honestly earning a living. Nobody objects. But slowly, the vendor clears a patch for dhania and herbs, then brings in a couple of cows for milk for tea. And the cows need to graze. A shed opens up. A family member moves in. And so the perforation grows. Quietly, incrementally, each step individually justifiable. And this is how roads enable forest perforation. And as each perforation expands, the edge effect, the zone of disturbance, noise, light, and invasive species penetrates deeper into the remaining habitat. As perforation expands, we reach the stage of fragmentation proper. The diagram shows the green landscape now broken into distinct, disconnected patches separated by a growing matrix of human activity. The photograph shows a tea plantation landscape where forest survives only on the upper slopes, with the valleys fully converted. In our story, this is what has unfolded from that first samosa shop. The stoppage point has become a small market. Trinkets, provisions, miscellaneous goods, everything is available now. Since vendors must come daily, hutments come up for convenience. And then comes the argument that wild animals are entering the herb garden and that children need protection from the ferocious beasts. Barbed wire fencing goes up around herb patches, around hutments, around the road margins. Each fence line is a new barrier cutting through the forest. What began as a road through intact habitat is now a corridor of fragmented, fenced, settled land with isolated forest patches on either side. This is fragmentation, not planned, not announced, but arriving step by step through a process that seemed reasonable at every stage. The final stage is attrition, the progressive shrinkage of the remaining forest patches. The diagram shows factories and industrial structures eating into the last green areas. The photograph shows a hill where everything except the very top has been cleared and replaced by plantation. In our story, this is what follows fragmentation. The settlement now has people, so the government provides electricity, water, sewerage, a health center, and a school. All genuine rights, all justified. And now the location has road connectivity, population, and full infrastructure. So industry arrives, mining, plantations, processing units, promising employment, GDP growth, and best use of available conditions. And all of them need space. And the only space that is left is the remaining forest. And so those last fragments are consumed in the name of public welfare and development. Notice that at no single step did anyone say, let us destroy a forest. Every decision was locally justified, and yet the cumulative outcome is the near complete loss of what was once a continuous habitat. This slide provides a before and after summary of the entire process. On the left, a solid green rectangle, continuous intact forest. On the right, after dissection, perforation, fragmentation, and attrition, only a few irregular scraps of green remain at the edges, surrounded by a vast matrix of human dominated land. And this is not the end of the story. With people now living deep inside what was once forest, there is easy access to the remaining habitat, to graze livestock, to hunt animals, and to collect honey, tuber, fruits, and other produce. That was wildlife food all along. Meanwhile, wildlife enters the habitation, depredates crops, and threatens the safety of residents, especially small children who have to live in fear of their lives. A perennial human animal conflict situation has been created now, and the wildlife is blamed for it, even though it is the wildlife that has been progressively pushed into smaller and smaller corners. What began with a road and a samosa shop has now ended here. This photograph brings that abstract diagram to life. It was taken in the tiger and elephant habitat and corridor area of Mudumalai. What we see on the valley floor is not wilderness, it is fenced resorts with manicured grass lawns, buildings, and bustling human activity, all sitting inside what should have been a critical wildlife corridor. The forested slopes in the background show what the landscape once looked like across the valley as well. Tigers and elephants that need to move through this corridor now encounter fences, lawns, and human settlements, where forest once stood. This is extreme fragmentation in a real, named, protected landscape. And it illustrates precisely why the samosa shop narrative we followed through the previous slides is not hypothetical. It is the documented history of landscapes like this one. The fourth impact is habitat displacement, the shifting of wildlife to non-prime or subprime habitats, such as hills or rocky patches. The photograph is an aerial view of Cape Town. Look at the flat plains. They have water, soil, and abundant food. They could support rich wildlife. Instead, they are entirely occupied by human settlement. The only space that remains is the rocky hills in the background. Less soil, less water, less food, and far lower carrying capacity for wildlife. And that is precisely where the wildlife has been displaced to. These hills may have served as a refuge earlier, but they were never the feeding grounds. Animals displaced there are surviving on habitat that cannot adequately support them. And wildlife is no match for the canes, guns, and dogs that come with human settlement. And so they retreat further and further into whatever marginal space remains. And here is the telling part. If you ask a local resident, they would say, but we live on the plains and the animals live on the hills. So there is no question of any conflict. The displacement is so complete and has happened so gradually that it is no longer even visible as a problem. And that is what makes habitat displacement one of the most underappreciated of our four impacts. And that is where we end today. Thank you for your attention. Jai Hind.